Hello everyone. Good evening. How are you all? Hope you all are good with your best of health. Am I audible, right? Let me know through the chat box quickly. We're going to start our session within 2 to 3 minutes, guys. Okay. Before that, please do text me in a chat box whether I'm an audible and my screen is visible to all of you properly. Let me know through the chat box quickly. Yes. Yes, guys, we will meet in a 2 to 3 minutes. Okay. Yes, okay, we'll start our today's session. Guys, before that, just record it. Right. This is also one of the weightage chapter in a second term. Okay, if you are considering for the board examination or NEET and JEE and even in KCET also. Okay, in all that sector, this chapter also very important. Okay, in last class I told that in optics we will get around 2 questions, correct now? In a similar pattern in wave optics also there will be a minimum 2 question will be appear in all the streams like JEE and as well as NEET in KCET, and moreover in your board examination also this chapter is having a good weightage right now. But in this chapter mainly important things are like that. First point is that interference of light, interference. Second one will be diffraction, and third one we are going to learn here polarization. Polarization, these are all 3 topics which are very highlighted topics in our chapter, because in ray of light we know that, right? In ray of light we studied the reflection, refraction, dispersion, uh, total internal reflection. Correct now? These are all the things which will be explained by the ray optics. Correct now? Here the interference phenomena, diffraction phenomena, polarization phenomena will be explained by the wave optics. Optics got 2 branches hai na. First one will be ray optics, second one is wave optics. Ray optics means here physical optics, ray optics, right? Wave optics का मतलब क्या होता है? Here we are dealing the phenomena of light with the consideration of wave, light as an wave. Okay. Cool. Okay, mainly we are going to discuss interference, diffraction, polarization, right? And meanwhile guys, when I'm explaining, no, if you are getting any doubt means please do text me immediately. Okay, don't be delayed. Cool. And wave क्या होता है actually? We'll start. What is the meaning of wave? Right? In your 11th standard, you might know that, right? If any disturbance will be produced in a medium, means that in that medium, energy will be carried out from one point to another point B. Energy क्या होता है? Carry होता है. Correct now? This phenomena is called the wave. Disturbance will be carry the energy. मालूम नहीं आना? Don't worry. Just imagine. इधर एक फिगर है ना, right? here एक फिगर है. Just a minute, I will explain. Here it's a water drop will be falling on a water surface. Correct? When it is fall down, no. Look at the surface. क्या हो रहा है? इधर एक wave create हो रहा है, disturbance create हो रहा है. Correct now? This is the disturbance which is created due to an external molecule. Correct now? This is the definition of wave. Just definition of wave means here we can write like this: disturbance created in a medium. Okay, this is a general definition for the wave. No problem, right? Okay, in this chapter mainly we are discussing about the wavefront. What is that wavefront? Wave तो पता हो गया. It is a disturbance produced in the medium. Wavefront क्या होता है? Right? Wavefront तो देखो इधर. I already told you, no? Just imagine this is the hill. Okay, in hill station it is attached with the river. It's a bank of river. Just imagine it's a bank of river. Actually, bank of river it is in calm position. Okay, you are sitting at this point. Okay, when you are sitting near the bank of the river, आपका एक जन्मसिद्ध हक होता है. Correct ना? What is that जन्मसिद्ध हक? Right from the birth. क्या होता है? ये पानी के अंदर एक पत्थर डालना. Correct ना? If you're going to throw a stone on this water, what will be happen? I already show you on image, no? There in a water, it is in a calm position in a beginning. Now when you throw the stone, no, this medium, river water medium is there, no, it will be get disturbed due to this stone. Right now, when it is get disturbed on the surface of the water, there is you might be observed that there is an wave will be formed like this. Right now, from the center portion to in all the direction. Correct? On a plane surface. We call this one as an wave front. Wave front का मतलब simple है, front side of a wave. Okay, front side of a wave we can call wave front also. Just generally we can call this one as an front side of wave. Here, front side of a wave can be treated as wavefront, but it is not an exact definition for the wavefront. Okay, it's a meaning for the wavefront. What I'm saying. Okay, how to exhibit the wavefront in a general in a particular definition means actually here the wavefront which is created in a plane surface, but we are talking about light, source of light. Correct now? Just imagine here a source of light is there. Correct now? This is the source of light. It emits the light in all the direction. Correct now? Here medium is there. We can call this medium as an air medium. Right? In the medium, it emits the light. It is in the form of wave like this. Correct now? In all the direction, will be in a three-dimensional figure. Right? When it is exhibits this wave, no. Now what we need to do actually, we need to collect the wavefront. We need to draw here. We need to write or join the crest point of all the waves first. like this. If you join the crest point of all the waves means we will get a wavefront. It should be in a spherical way. It is in spherical way because here we are writing here the bulb or the light which is emitted in a, all the direction, 3-dimensional, right? Okay, crest point ka ho gaya. Trough also there, no, these are up, these are down. Look at here, one more figure is there mere paas. In this figure you can clearly identify this is the disturbance which is produced in the medium. Due to disturbance wave is created like this, correct? Now this is the trough point, crest point. This is the trough point. This is crest, this is trough, this is crest, this is trough, this is crest, this is trough. Okay, it is actually spreading in all the direction, correct? Here also it is there like this, correct? Now if you're going to join all the points, locus of all the points in a crest like this, you will get a wavefront. You will get a wavefront. But in this case, light is a 3-dimensional. No, that's why we are writing this one as an spherical wavefront. Clear? This is a crest wavefront. Similarly, trough wavefront you want means you need to join all the locus of the points of the crest. Sorry, trough. Correct now? Then it will give the crest trough wavefront. Right? I will draw here. देखो इधर एक बार. Green color में dotted lines. These are all the. This is also wavefront which is created due to trough. Clear? But here it is a spherical wavefront. Actually, spherical wavefront क्या होता है? Every point on the given wavefront acts as a source of new disturbance. No worries. Okay, leave it. Actually, it's an joining of a locus of all the points on the crest points. क्या करना है इधर? अरे यार, क्या हो रहा है इधर? Simply just remember this one. Joining all the locus of point on crest or trough. Okay, it gives wavefront, but in this case it will give the spherical wavefront. Clear? Wavefront में 3 types है basically. Okay, first one is spherical wavefront. Second one क्या होता है देखते हैं. This is a spherical wavefront. What if in case I'm going to take a linear source? Linear source means tube light होता है ना, tube lights. देखो इधर. This is a tube light. Yellow color है. Actually normally white color मिलता है. Correct? Right now, एक tube light क्या करता है actually? Disturbance करता है medium में. Due to the disturbance, the light will be flowing in all the direction. Correct now? You might be observing this figure. Due to this figure, wavefront can be written as in cylindrical ways like this. Linear source along a circular. Now, this is a just a minute like this. They will move. Correct now? This is a cylindrical wavefront. And last one, plane wavefront. Plane wavefront कैसे होता है? Actually देखो, this is a source. This is a source of light. Source of light which gives the disturbance in a medium and it emits the wavefront. Just imagine these are all the wavefronts which are in a forwarding direction. Okay, at what infinite position for a long distance if it is travel means wavefront क्या होता है? बहुत बड़ा होता है. It has a long wavefront. This is actually we call the wavefront. Okay, wavefront nothing but front side of a wave. That's it. Already I told you. Here you just look. If you're going to take this small portion, if you're going to take this small portion, how it is to be looking like? Plane. Correct now? Here, if you're going to mark this one as an end A, end B means this point is called the plane wavefront. Plane wavefront. Clear enough? Wavefront is nothing but just we need to join all the locus of points of a crust or a trough. Due to that one image will be formed of a wave that is known as the wavefront here. Clear? And they might be asked the what is the relation between wave front and ray of light? Like this, they will be asked question. What is the relation between them? This is actually wavefront, which is going outward direction. Correct na? Ray of light कैसे डालते हैं आप? Actually, this is source means white light इधर है ना? Straight line. This is what the ray of light. This is ray. Actually, ray of light, which is always perpendicular to the surface of the wavefront. देखो इधर. Here in plane wavefront also, if you want to write the ray of light in the plane wavefront, means just draw a perpendicular line over them. Correct now? Then it will give the relation between ray of light and as well as the wavefront. Clear? Then what is the angle between them here? Wavefront surface to the ray of light. Let me know through the chat box. What is the angle? Angle कितना होता है? Yes, that is all about 90 degree. Clear enough? Here also you might look here. Either cylindrical wavefront is created. No, if you write a perpendicular line like this, just a minute, I will take a black color, then it will be good for observing. Look at this is the ray. Correct now? This is also a ray. Correct? Almost all these rays are perpendicular to the wavefronts. Correct? This is what the relation between wavefront as well as the ray of it. Angle, already I told you, angle between them will be 90 degree. Clear up? Is it clear? Is these 3 points are clear, right? Okay, if it is clear means next we are going to learn about one principle, that is Hygiene Principle. Actually guys, Hygiene is an scientist. He actually explained this wave optics completely. His one imagination theory will be going on, created on the wave optics. Okay, that is called the Hygiene Principle. Actually क्या बोला था ना Hygiene? Wave optics में light is an electromagnetic wave. Correct na? Any energy which is traveling means it requires one medium. Right? In that case, Huygens also thought like that in the beginning. Light is coming from space, from the star to earth means from earth surface to some certain distance there is an atmosphere, medium is there. From the sun to earth, from sun to atmosphere distance there is no medium. Correct now? He thought like that, yes, energy is carrying means some medium is there between sun to atmosphere also. Okay, this medium he called ether. He called this one as an ether. It's a highly sensitive density it has and malleable one. Correct now? And this medium doesn't have any massive particle. Like that, he had an hypothesis. He created that hypothesis like that, but later on it is proved that it's a wrong theory. Means this ether is not present there. Okay, a light is an electromagnetic wave without medium also it will be travel in a space like that. They will Einstein will be proved. No worries. Okay, atmosphere को enter होने के लिए he thought that there is an ether medium. Okay, leave it. And also he give that some statements about the wave optics. क्या होता है वो? Just look at it. This is a source, right? This is what the source of light. Okay, source of light means it will emit the light radiation all the direction like this in the terms of wave. Already I told you. Correct? If you join a crest point of all the waves, means locus of all the points of a crest point, if you're going to join means you will get a wavefront. right? Here, this is what the first wavefront. What I'm writing now, 1. This is what the first wavefront which is coming here. Okay, actually they took second one, no problem. This is what the first wave, which is a wavefront which is created by this source. Now क्या होता है ना, actually this wavefront is moving in forward direction. The reason behind this one, what is stated, no, on this wavefront, first wavefront is there, no, this is what wavefront, guys, wave front. On this wavefront, infinite number of particles are present. Infinite number of particles are present like this. 1, 2, 3. I can't write infinite now. That's why in limited value only I will write. Okay. These particles we called wavelets. We call these particles as an wavelets. Actually, इसका काम क्या है ना? These wavelets are acting like a source of that particle, source of that source of the primary one. Okay, these wavelets are the source of light of the primary one. Like that they are behaving. Correct now? This is a source means again this source what it creates actually wavefront create करता है. This source also creating a wavefront. Again this wavelets creating source means wavefront. Like this wavefronts will be created due to these wavelets. Now in the forward direction, second point what you say, no, in the forward direction of all the wavefront, we need to draw one tangential line. Correct now? Now it will give the secondary wave front. This is called the secondary wave front. Listen, once again I'm going to tell you, actually a source of light is that means light will be emitted in the form of wave. Correct now? Light is emitted in the form of wave. If you're going to join all the locus of points of the wave of a primary wave means क्रस्ट पॉइंट में ज्वाइन करने से एक वेव फ्रंट मिलता है, इसको हम कहते हैं प्राइमरी वेव फ्रंट. कूल. नेक्स्ट क्या होता है, ये प्राइमरी वेव फ्रंट के ऊपर जितना पार्टिकल होता है ना, वो ऑल द पार्टिकल्स आर बिहेविंग लाइक अ सोर्स ऑफ दैट लाइट from where the source is emitting light, no, they are also behaving like a, we are also part of that source. That's why we are also source of light. And again these particles also start to emit the light, and when they emit the light again, if you want to draw the, if you want to join the locus of all the points of a crest point means again one wavefront will become on the surface of this wavelets. Right now this is called the secondary wavefront. प्राइमरी वेवफ्रंट के साथ सेकेंडरी वेवफ्रंट भी आ रहा है उसके फॉरवर्ड डायरेक्शन. एंड सेकेंडरी वेवफ्रंट है ना, उसके ऊपर अगेन पार्टिकल्स होता है. करेक्ट ना? लुक एट हियर, रेड कलर वाला पार्टिकल्स होता है. ये पार्टिकल्स अगेन दे आर बिहेविंग लाइक वी आर आल्सो सोर्स ऑफ लाइट. लाइक दिस we are also source of light. And this wavefront, front side of all the crest point, if you're going to join means again one more wavefront is creating. This wavefront we call tertiary wavefront or third wave front. Again in the forward direction, again some particle which are present on the third wavefront, no, they are also behaving like a source. And like this, in this phenomena only the light energy will be carried out in a forward direction. This is the principle which is given by the Hygiene. Correct now? This is principle, guys. That's it. Actually this whatever I told no here, this is all about for the spherical wavefront. If the spherical wavefront will become very forward direction means इतना बड़ा spherical front है, इसके ऊपर if you're going to consider from this point to this point, just look at this portion. ये भी how it is looking like, it is looking like a linear one. Correct now? Here also infinite number of particles are there on this portion AB. Correct now? This particle how it will be behave, actually they are also like behaving like a, I'm also source of this light, primary source. Correct now? Like this they will emit the waves. Correct? Now, if you're going to join the crest point or trough point of the wave in a front direction, means again one more wavefront will be coming. A become another wavefront, A dash, B dash. Look at here how it is looking like. They are looking like parallel to each other. Means these are the plane wavefronts. Means in a plane wavefront also the particle will be behaving as the same like a spherical wavefront. Clear? Hope it is clear. Correct now? And one more point, guys. One more point. Just imagine A, B is a wavefront, and the further next coming wavefront will be A dash, B dash. A dash, B dash means here from this point to here some distance is there. This distance. We need to calculate this distance. How to calculate the distance? Actual distance ka we know that velocity is equal to displacement by time taken, or speed is equal to distance by time taken. Yes, speed is nothing but speed of light. Distance चाहिए तो t को इधर multiply कर दो, आपको मिलता है c into t is the distance between two slits. Clear? Hope it is clear. Let me know through the chat box quickly. Or else if you have any doubt means please do pass your doubts in a chat box. Excellent. Okay. Next, coming to the reflection of light. How the reflection of light will be, actually ray of light obeys the reflection, refraction, everything. No, here also we need to prove that one reflection, refraction through the wavefronts. Correct now? For that reason, what I will take, just imagine here एक mirror है. ये क्या है? This is the mirror. Okay, this is what the mirror. Okay, mirror के ऊपर any ray of light which is incidenting means it will be reflected. Just imagine this is a wavefront which I am going to consider here. This is a wavefront. A, B. From this source, it is coming. Actually, source it is there. No, it is at infinite distance. Just imagine that infinite distance से कैसे होता है? ऐसे होता है. At one point where I am considering, no, here I am considering this portion of this spherical wavefront. Means it is nothing but a plane wavefront. कौन सा wavefront I consider here? Plane. Plane wala, right? Plane wavefront. This plane wavefront, again on this plane wavefront we know that jitna particles hota na, they are behaving like a wavelets. Means it is nothing but source of light. In this forward direction में क्या करना है? Again we need to draw a plane wavefront joining the locus of point of all the wavefronts. Again क्या मिल गया आपको? Wavefront मिल गया, plane wavefront. In this light, similarly the wavefront will be moved A, B, and finally again at one particular point B plane wavefront, it touches the mirror. B क्या कर रहा है? Mirror को touch कर दिया. Correct ना? But A still it is in a A. Right? Now after touching B, these particles क्या करना है? Move करना है. किधर? Reflection होना चाहिए. If these are the particles which are present on the wavefront. Correct now? Now these B particles are there. No, they are start to reflect in this direction. Reflection होना चाहिए ना? Right? Up to this point, A points up to what time they might be asked. Up to this A particles are there. No, this A particles they are all reaching the point A dash at this point of the mirror. Here A to A dash, whatever the distance is there, no, I'm writing here A to A dash, distance is there, no, distance already I told you last time only, means in the last क्या है वो wavefront में how to calculate the distance. It is nothing but multiplying the speed of a light into time. Correct ना? ये distance cover करने के time में this distance A to A dash, this particle will cover the distance. So in the same time, B particle will reach up to this point, B dash. Clear? Now क्या करना है हमको? Again we need one plane wavefront, reflecting plane wavefront. क्या करना है? From A dash to B dash का plane front है ना, उसको एक tangential line खींचो 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 खींचो. Now look at here. AB is there? No, here. Just a minute. हाँ, AB, it is the incident wavefront बन गया. Correct ना? A dash B dash is there? No, A dash B dash. It will be reflected wave front होगा. Correct? In this reflected wavefront again, all the points there is an wave particles. They are acting like a wavelets. Don't forget it. Right? Wavelets again in the forward direction. You need what you need to do. You need to draw one tangential line on all the surfaces. They are parallel to each other, and again parallel to each other, parallel to each other, parallel to each other. In this way, they will be get reflected. Now the term is that reflection होता तो क्या होता है actually? We need to prove angle of incidence equal to angle of reflection. This is what the statement no, law of reflection. Now look at here. For the point B, is there? No, here. From point B to B dash, I will draw one line, perpendicular line. Okay. And then A to A dash already is there. The angle, whatever it is created here, no, from the plane mirror, we call this one as an angle of incidence. This is what the angle of incidence. Either side. Clear now? And then from the B to here, A dash to A is there? No, we call this one as an angle of refraction. Here, दो ट्रायंगल बन गया है. अच्छे से देख लो. एक ट्रायंगल है B A A dash और एक ट्रायंगल है B B dash A dash. These are the two triangles. Actually, listen. From B to B A dash, from B to A dash, the distance it is traveled by the wave particle, it is nothing but guys C into T. Here it is there, no, C into T. Similar way, in the same time, from B to B dash, the distance traveled by the wave will be again C into T होता है. एक side equal होगा. And then the angle from this figure इधर देखो, from B to A dash is there? No, this is the same distance. This is the same distance which will be traveled by the two waves. Means B to A dash are same for the two waves. Third one, look at here. This is the right angle triangle. Here also it is right angle triangle. Means all the angles of these two triangles are equal. Correct now? We can call this one as an congruent angles. Congruent triangle. Correct now? If congruent triangles are there, means if the angle which is created from the mirror to the B line, B to B dash, will be angle of incidence. Here it will be created in opposite side, angle of refraction. Actually angle of incidence किधर बन रहा है? देखो, B to B dash to mirror. Angle of refraction किधर बन गया है? A to A dash with respect to mirror. Correct now? From this point only we can clearly say that the wavefronts, from using the wavefront also we can prove that angle of reflection is equal to angle of refraction. This is what about the reflection of light. Cool. Hope it is understood, right? Cool. Coming to the next point, refraction of light. Second phenomenon. Refraction of light क्या बोलता है actually guys? Refraction of light. We have an equation, no, sine of the angle of incidence by Sine of the angle of refraction is equal to a constant value mu. This is what the refraction. Correct? Now this is what actually we need to do. Now imagine A, B is the wavefront, which is actually traveling in air, refractive index 1. This is the mu2. Just assume this is a water. Okay, refraction takes place होता है. A B के ऊपर ये particle है, इधर एक particle. Infinite number of particles are there in the wavefront. Already I told you. Due to this one, in a forward direction, wave will be carried out. Correct now? Either A particle will touch this point. No, A particle. At that time, B particle will be present in air only. Right? When up to the point from B to B dash है ना, ये distance cover करने के time क्या होता है ना? ये distance cover करने के time. What is that? B to B dash distance here again C into T. Right now, in the same time, this is what the distance ज़्यादा होता है. But when it is traveling from air to denser medium, speed of light decreases. Hence, wave speed also decreases. The wave will be displaced up to this point only. A dash. Right now, with the speed of light to C into T. For our convenience, here speed change hota hai na. That's why what I will write here, instead of C, I will write V1, V2. Clear? Khel khatam, natak band. Correct? Right? What I'm saying? Carefully observe here. From A to B, this is a wavefront, and here it is creating an angle. This is called the angle of incidence. Is it angle of incidence? Check करो एक बार. Last में बोला था ना. This is the angle of incidence. Right. From B to B dash होता है ना. From this point onwards, the B particle will start to refract like this. Correct now? Now from the B point to surface, whatever the angle which is creating, no, here it is called angle of refraction. Angle of refraction. Triangle क्या बन रहा है इधर? A to B dash इधर, yes, like this. Correct now? Now we need to prove this equation. Then only we can identify that. Then only we can say that sine of angle of incidence by sine of the angle of refraction will be equal to constant value mu. Correct now? Okay, to prove that one, guys. Now we'll apply the sine rule. Here sine of angle है ना, ये angle है ना, sin I. इसको sin को apply करो. Sin क्या बोलता है actually? Trigonometric function opposite by adjacent side. Correct now? Opposite side क्या होता है इधर? B to B dash. B dash divided by adjacent क्या होता है? A to B dash. A B dash. B dash means V1 T divided by A B dash, we don't know, right? Like that only. Okay. Sin R क्या होता है? Sin R again adjacent. Okay. Sin R क्या होता है? Is it right what I'm writing here? Opposite by adjacent है क्या ये? Hypotenuse होता है ना? No one inform me, right? Sin function क्या होता है यार? Opposite by hypotenuse. Sin R again opposite by adjacent. Sorry, hypotenuse. Why it is coming opposite by adjacent? This tan no. Shut. Hypotenuse. Correct ना? Opposite side क्या होता है? Angle R को A to A dash. Correct ना? A to A dash divided by hypotenuse side again A B dash. Correct? Now A to A dash means this is the speed distance traveled by the wavelength. Correct now? What is that? V2 T divided by A B dash. T same है. In this condition only we are proving this one. Now put these two values in this equation. Sin equation. क्या होता है देखो एक बार. Sin I means here V1 T divided by A B dash. Correct now? Into Sin r is there, no? I'm writing here, that is v2 t into a b dash, a b dash, a b dash मर गया, t t हो गया, खत्म कहानी. It is equal to mu. v1 by v2 हो गया, v1 by v2 is equal to mu. Correct? Now what I am saying, v1 by v2 क्या होता है guys? Speed of light in a second medium with respect to speed of light in a first medium. Actually it is equal to mu1 by mu1 mu2 by mu1. Right, right now. This is speed in terms of, right? We can say this one as an this equation, no? We can indirectly say this one. Listen, no? C1 by C2 or V1 by V2 means here it is nothing but refractive index. होता है ना, refractive index के लिए एक formula लिख दिए थे हम, पता है ना? We are measuring the speed of light with second medium with respect to the first medium, right? Then we can say this one, or else we can write this one like this also. Listen, V1 by V2 is nothing but mu. This is mu2 by mu1. Correct what I'm saying? This is actually equal to sine of the angle of incidence by sine of the angle of refraction. From this point, we can clearly say that refraction of light also takes place with the help of wavefront. Correct? Still you have any doubt? Hope it is clear. Next, now we have to analyze the behavior of optical instrument with a wave. कैसे behave होता है? देखो इधर एक plane wavefront लेता हूँ. First I am going to discussing about the prism. Okay, एक plane wavefront है इधर. Plane wavefront को आपको पता है ना? A B. Actually it is traveling in air here. It will be come and incident on this prism. This is A. This is B. At these 2 points, particles are there, no? We call this one as an wavelets. These wavelets क्या करता है actually start to travel through the prism. Either A particle will be traveling in air. If it is travel this much distance, means B will be travel this much, because it will be get struck by the medium. Medium में speed of light decrease होता है ना? Now from B particles, if they are reaching the point, this one means B dash, during this time A particle will reach this point A dash, because A particle के लिए medium बहुत छोटा सा मिल गया distance. B point suffers a lot, means it lags behind the A particle. Correct now? Now we want this, the refraction takes place in a prism. Now if you want to write the wavefront, means just draw a tangential line on this wavefront. Now it will become a dash B dash. Correct now? Again on this particle will move in a forward direction as a wavefront, like this, like this, like this. Correct now? This is what the behavior of a wavefront in a prism. इधर आप क्या कर दिया? Plane wavefront incident कर दिया. Correct ना? After refraction plane wavefront मिल गया, right? Plane wavefront ही मिल गया. First हो गया. Second क्या होता है देखो. Again I'm going to consider the similar plane wavefront A B, but in this time I'm going to introduce or incident this plane wavefront on the concave mirror. Look at here, this is a concave mirror. Aperture क्या लिखना है यार, इधर क्या लिखना है? आप भी सजेस्ट करो क्या लिखना है इधर अपर्चर को, क्या लिखना, क्या नाम देना है इसको? We'll give this aperture as 1 2. कलर कौन सा सूट होता है? black one. Correct. 1, 2 is the aperture. Correct. Now, if the ray of light, actually they are already I told plane wavefront. These are the plane wavefront. A, B, they are coming towards the concave mirror like this. They are incident here at point A, B. I will write in a green color. देखो इधर. This is A, this is B, incident. But here one point is there. I'm going to call C. This point not an incident still. Still it will be travel this much distance. From C to C dash distance. What it travel? No, this distance. While in the same time, from the particle A will be start to travel in opposite direction. Particle B also start to travel in opposite direction. In the same time, here now the A particle will become here A dash, B particle will become here B dash, C particle still it is incidenting on the surface. Correct. Now if you're going to draw one tangential line on all this particle, no, like this wavefront which is available. Correct now, like this. Right? Actually, you are incidenting here. You people are incidented here, plane wavefront. Incident here, plane wave front. Correct now. But after reflection, you are getting here spherical wavefront. Spherical wave front. Clear? Now, this wavefront actually converging wavefront. Second point क्या होता है? Converging wave front होता है. Because the convex mirror का काम क्या है? Light which is falling on this one, falling on it one means it will be convert the light rays. Correct na? That is what its work. Here wavefront also get converges. Clear? Okay. Coming to the next one. Convex mirror में क्या होता है? ट्राई करो एक बार. 2 मिनट टाइम देता हूं मैंने. ट्राई करके बताना है. If you want to incident the plane wavefront, and then after reflection, what kind of a wavefront we will get? I want to know through the chat box. I will give you exactly 2 minutes of time. Is it done? What kind of wavefront you got? देखो इधर देखो. Convex mirror है ना? Convex mirror ऐसे बनता है. Right? This is what the convex mirror. सुनो इधर. सुनो ना. हाँ देखो. प्लेन वेवफ्रंट को इंसिडेंट करना है. ए बी, ए पार्टिकल से बी पार्टिकल तक बहुत वेवलेट्स होता है. Similarly, in a forward direction it will be move. In forward direction it will be move. In forward direction में it will be incident on this concave mirror. A and B particle will not incident yet. Correct now? But here before that another one particle, if you're going to say C, it already incident on this concave mirror. Yes, but A and B क्या करता है? They are still traveling in A. Correct now? When they reach point B and B part B A dash this one B wavefront, when they reach at point B dash, correct now? During the same time, C particles will be come back up to this point. Are you getting my point? Correct now? Now C dash will be present here. This is C. Now what we need to do actually, all these particles को join करना है tangential line डालकर. इधर क्या होता है देखो, this is a tangential line for this wave, this is a tangential line. It is wavefront created. This is the wavefront which is created. This wavefront का particle again it will create the wavefront in forward direction like this. Again, like the particle which are present in this wavefront creates the another wavefront like this, like this. क्या हो रहा है? Wavefront बढ़ रहा है, means diverge हो रहा है इधर. Diverge कैसे हो रहा है? क्या करना है आपको? From this particle you need to draw one perpendicular line over it. Correct now? It will give the definition of diverging and converging. देखो एक बार rays को देखो. These are the light rays. Correct now? They are actually emerging out in all the direction. ठीक है ना? This is all about in convex mirror. Okay, convex mirror में क्या होता है? Result मैंने नहीं बता दिया. Your incident light क्या होता है? And reflected light क्या होता है? बताना है. Incident light क्या होना है इधर? कौन सी तरह के इंसिडेंट लाइन? प्लेन वाला, प्लेन वेव फ्रंट. करेक्ट ना? रिफ्लेक्टेड वेव फ्रंट कौन सा होता है? स्फेरिकल वेव फ्रंट. स्फेरिकल वेव फ्रंट. उसके साथ साथ वेव फ्रंट कौन सा तरह होता है? दे आर एक्चुअली डाइवर्जिंग. प्रीवियस में कन्वर्ज हो गया था. Cool. These are all very important for the CBSE board exams for 2 marks question like that. Be aware of it. Next one is that convex lens. Okay, convex lens में क्या करना है? Again we need to incident a plane wavefront AB. Okay, when it is incident at this point, no, AB, right? But C point incident very fast. Here क्या हो रहा है? Transmission हो रहा है through this optic. Correct now? From point C to it will reach C dash. Here it has a higher denser medium. Correct now? When the wavefront will be reached from point C to C dash, within same time A particle and as well as B particle will reach up to this much. A dash will be here now and C dash B dash will be here now. Correct now? Now again we need to draw a tangential line over the A dash C dash B dash and wavefront मिल गया. फॉरवर्ड डायरेक्शन में ऐसे फ्लो होता रहता. करेक्ट ना? लुक एट हियर, दिस इज द लाइट डायरेक्शन. लाइट डायरेक्शन में देखो इधर एक्चुअली wavefront which is converging. Simple bro. Actually look, देखो इधर the wavefront which is converging means radius क्या होता है? Keep on decreases. देखो एक बार, radius keep on decreasing. Radius keep on decreasing means here converging wave front. It's a converging wave front. Clear now? Actually, what kind of wave front you incident? Plane wave front. Done. Khatam. In this point only, I would like to give one homework to all of you. क्या होता है प्लेन वेवफ्रंट को कॉनकेव लेंस के ऊपर इंसिडेंट करने से? If you are incidenting a plane wavefront on a concave lens, right? what kind of wavefront you will going to get, and you need to write the diagram. This is the way homework which I'm going to assign you. This is homework. Don't forget, guys. Okay. Okay, cool. This is all about behavior of a wavefront with the optical instrument. Cool. Next one क्या है? Superposition principle. Superposition principle means we know that superposition principle we studied in electrostatics to add the electric field for all the points which are present in a field. Right? क्या किया था हम? Just we added the electric field lines along with the vector addition. Correct ना? Vector summation or vector addition करना पड़ता था. Here also superposition principle means if two waves are present means we need to add the two waves amplitude. Two waves का amplitude को add करना है along with the vector addition. Well, along with the vector means direction के साथ add करना है. देखो इधर in this figure, guys, look at here. Either I'm writing in a red color. No, this is the first wave. This is the first wave. I'm going to call this one as an y1. Equation of y, so y to wave equation बनता है. I will call y1 as a first wave. I'm going to take another one wave without any phase difference and path difference. It is traveling with a first wave. I'm going to call this one as an second wave. Correct ना? Two wave बन गया. Now उसका amplitude किधर से measure करते हैं? From the mean position से. From this point, what amplitude? For the first wave, amplitude is that A1. For the second wave, amplitude is A2. Correct? Now we need to add the two equation. Means indirectly we are adding the amplitude of these two waves. Vector addition बोल दिया मैंने. Correct? इधर देखो. This is the first wave. Right? Second wave. This is first wave. I will write. थोड़ा सा ऊपर लिखता हूँ मैं. हाँ, like this. Correct ना? Amplitude of A1. This is the amplitude of A2. ये दोनों amplitude को add करने से क्या होता है? Vector addition means in the same direction are there. That's why this will become A1 plus A2. This is what the general vibe. A1 plus A2 होता means amplitude ये दोनों के जैसे बड़ा होना चाहिए. Correct now, if you take numerical value A1 is equal to 2, A2 is equal to 3 means दोनों का summation कितना होता है? 5 होता है. Then resultant amplitude किधर आता है? In the same, without any path difference and phase difference, it will be brown like this. इधर देखो dotted line में show किया है. This is what we call wave. This is the resultant wave. Means if two waves are in the same direction, are you getting my point? If they are going to superposition principle means if you're going to add them in a vector addition means the resultant wave का amplitude क्या हो रहा है? ज़्यादा हो रहा है. We call this one as an constructive superposition. We call this one as an constructive superposition. Construct हो रहा है. Construct means develop होना है. Constructive superposition. Okay, एक हो गया. देखो इधर y1 तो इतना था, y2 थोड़ा बड़ा था. ये दोनों मिलकर बड़ा सा वेव एम्पलीट्यूड हो गया. Similar way, if I'm going to take the two waves which are having a same amplitude or a different amplitude, y A1 का amplitude इधर है. This is the A1 का amplitude, and second one wave, second one will be here. This is the second wave. Second wave is the first wave. But first wave का amplitude है देखो इधर 3 meter. Just imagine amplitude A1 will be 3 meter. Second one का amplitude बन गया 2 meter. Okay, 2 units and 3 units. Now vector, in addition to vector, we need to add these two waves along with the vector addition. Then actually here क्या हो रहा है? Y y1 प्लस y2 करना पड़ता है, करेक्ट ना। y1 का वैल्यू कितना है 3 है, राइट, प्लस y2 का वैल्यू कितना है 2 है, बट इट इज इन ऑपोजिट डायरेक्शन फॉर द फर्स्ट वन, देन यू नीड टू डू -2, देन रिजल्टेंट वेव का वैल्यू कितना होता है +1, means it will become in a positive y-axis here. It is shown now dotted line. This is what the resultant amplitude means. Here it is saying that resultant amplitude क्या हो गया कम हो गया, means इधर distract हो गया. We call this one as an distractive superposition principle. It means that if the two waves are having the amplitude in the same direction, means राइट, उसका रिजल्टेंट एम्पलीट्यूड होता है बहुत ज्यादा, है ना। इफ दे आर इन ऑपोजिट डायरेक्शन मींस इसका रिजल्टेंट वेव का एम्पलीट्यूड होता है लेस देन दिस टू वेव्स। क्लियर है ना बात। दिस इज व्हाट अबाउट द प्रिंसिपल ऑफ सुपरपोजिशन। ओके एंड गाइस दिस इज ऑल अबाउट टुडेस क्लास। ओके वी आर गोइंग टू continue the class of the wave optics from tomorrow with coherent source and non-coherent source and Young's double slit experiment and majorly the question which are appeared in the previous examination. No, in NEET JEE we are going to solve those problems in a tomorrow class. Until then, take care. Bye bye. We'll see you in a next class. Okay. Bye.